Hello everyone, Jason here. I am going to do an optimization example problem. So let's take a look. All 80 rooms in a motel will be rented each night if the manager charges $40 or less per room. All right. If he charges $40 plus X per room, then 2X rooms will remain vacant. If each rented room costs the manager $10 per day and each unrented room costs $2 per day in overhead, I guess they got to clean the rented rooms, how much should the manager charge per room to maximize his daily profit? And this is what optimization can help us with. Optimization is all about maximizing or minimizing things. In this case, we want to maximize profit. Well, I suppose if he has 80 rooms and he charged $40 a night, that's $3,200. And then we have to subtract off his costs for cleaning and such, power. What is it, 80 rooms times $10? What's that, 800? So what do we get there? We get 2,400. All right, so if he were to do nothing, if he were to rent the room for 40, he'd get 2,400. So let's try to beat that. So how can we do that? Well, let's say maybe if P is the daily profit. Let P be the daily profit, and we want to maximize the profit. To maximize the profit. All right, so profit is going to depend on X. Because as if we increase the price, a lot of rooms go vacant. So I would say the total revenue is, so total revenue, we'll call it R for revenue, is equal to the price of the room, which is $40 plus X, times the number of rooms rented. Well, there's 80 rooms in total, and 2X will remain vacant. So 80 minus 2X will be the number of rooms that are rented. And that's going to equal, we have to FOIL this out. What do we get? 3,200 minus 80X plus 80X minus 2X squared. So we get 3,200 minus 2X squared. So that's revenue. All right. So what about total cost then? So the total cost would be, I'm going to call that C, is, well, they said it's $2 per each unrented room, so it's 2 times 2X, plus $10 for every rented room, and that's 80 minus 2X. So that gives us what? 4X plus 800 minus 20X, which equals 800 minus 16X. Good. So now we can combine these two. So the daily profit is, and of course profit is the total revenues minus the total costs, which in our case is going to equal 3,200 minus 2X squared, which is the total revenue, minus the total cost, which is 800 minus 16X. Don't forget your brackets. So what do we got? Let's simplify this a little bit. So we got 3,200 minus 2X squared minus 800 plus 16X equals negative 2x squared plus 16x plus 2400. All right, so that is my profit function. I'll put a nice box around that. There we go. So that's my profit function, my daily profit function. So when I'm maximizing things, I probably want to maximize my profits, right? So we will find the critical numbers. Find the critical numbers. From the derivative. From the derivative. So let's find the derivative. So that means my dp over dx is going to equal negative 4x plus 16. And then remember, when we want to minimize or maximize things, we're looking for the critical values. And these occur when the slope of my tangent line is 0. So what we'll do is we'll set this thing equal to 0 and solve it. So if I do that, I get negative 4x equals negative 16 divided by negative 4 divided by negative 4. I'm going to get x equals 4. So you might be thinking, well, is this a minimum or a maximum? Well, I can tell by my equation that this is going to be a parabola that's upside down, so it's a maximum. However, why don't we do something interesting and check? And check the critical number. And we're going to use the second derivative test. And remember, the second derivative test talks about the concavity. All right, so if the second derivative test gives us a negative number, that means we're concave down, which would mean a maximum. And if the second derivative test gives us a positive value, then we're concave up, which means we'll have a minimum. So I want to calculate the second derivative of this thing. So that's going to equal negative 4, which of course is less than 0. So the critical number gives us a local maximum. Since this is the only critical number and it is a local maximum, it's the absolute maximum. So the manager makes maximum profit by charging $40 plus 4, which is $44 per room per night. 44. Then you might say, well, how much is it going to make? So what we would do is we would just plug the 4 back into our profit function. What was my profit function? Negative 2x. So it's going to be negative 2 times 4 squared plus, I think it was 16x, so that's 16 times 4 plus 2400. Let's just make sure. Yeah. So this is going to equal, what's this? Negative 2 times 16 plus 16 times 4. What is 16 times 4? 72? No. 64. My bad. 64 plus 2400. So this thing is going to equal, what's that, minus 32 plus 64 plus 2400. Looks like this is like $24.32. That's what his profits are going to make, which is definitely more than he was making before if he rented all the rooms out, because he'd only make $2,400. So he makes an extra $32. With all that work, makes an extra $32.